Alaska is a land of immense natural beauty, shaped by dynamic forces of nature. Tectonic plates collide to generate some of the world's most powerful earthquakes. Seasonal temperatures can vary over 140 degrees. And now a changing climate is melting our glaciers and permafrost. A great challenge here is to build and maintain a safe, sustainable transportation infrastructure in this dynamic Arctic environment. And one University of Alaska Center, part of the Institute of Northern Engineering on the university's Fairbanks campus, is a leader in taking on cold regions transportation challenges.
The Alaska University Transportation Center is an organization focused on improving transportation, not only for Alaska, but also all of the circumpolar nations, as well as the northern tier states. AUTC not only focuses on highway transportation, we also focus on railroads, pipelines, aviation, and other transportation infrastructure.
We're seeing that the infrastructure, as it ages, there's a lot of investment needed to bring it back up to speed, to address very critical issues like congestion, safety, and many other problems.
Alaska has 24,000 earthquakes a year, of which at least one of those exceeds 7.0 in magnitude. However, unlike most places, we also have frozen ground, and that frozen ground affects the structures differently than they would in thawed ground.
Fairbanks, Alaska's second largest city, is particularly vulnerable, with only 2 major access routes.
And if we lose 3 bridges along those routes, Fairbanks will be cut off entirely from land-based transportation.
Help!
To help minimize this potential, AUTC has partnered with Alaska's Department of Transportation at a research site in Fairbanks to test a bridge pier under different conditions.
Seasonal effects, frozen ground effects, makes a tremendous difference in the behavior of these bridges during an earthquake. So now the question is, how do we design for that?
By applying increasing vertical loads to a bridge pier until it fails, researchers are looking at how it will respond. Instruments including strain gauges, inclinometers, and thermistors to measure temperature will provide useful data.
4.606, 43.2.
This is the first of a 2-part study where the soil is fully thawed right now, and so we're looking at what its response is now, and we're going to compare that to what its response would be when the soil is frozen.
This project also includes a real-world component, where a new bridge in Anchorage is being monitored for seismic and seasonal effects.
The goal of this project is to provide some recommendations as to how we would modify our previous design or even codes so that our bridge system would perform better during a winter earthquake in the future.
The other real critical part of the University Transportation Center is to develop the transportation workforce in this country and in Alaska. Nationally, what we're seeing is a shortage of technical people and engineers. And these people are critical for designing, building, and maintaining and planning transportation infrastructure.
By offering hands-on research to both graduate and undergraduate students, AUTC is helping develop that workforce.
Our climate is changing, our infrastructure is changing, our expectations are changing as Alaska grows. We can't just simply do the things we've always done. We have to move forward, and the only way we can move forward is by trying new ideas, new concepts
That's where innovation comes into play, and that's the role of the University of Alaska Transportation Center.